I slept on myself for way too long. I underestimated the gifts that God gave me for way too long.
Welcome entry lessons students. Today we're going to be doing generator and motor calculations, guys. And to get onto it, let's start with the first question, guys. The first question goes like this: a shunt wood generator with a shunt field resistance of 200 ohms and armature resistance of 0.5 ohms supplies a 40 ampere of a voltage terminal of 250 volts. Calculate the armature current, the EMF, and the power delivered in kilowatts. So let's write down the given. What is it that we are given, guys? We are given a shunt wood resistor, which is a shunt, which is equal to 200 ohms, and armature resistance RA, which is 0.15 ohm, supplies at 45 ampere, which is I 45 ampere, which is I load at 45 A, and a voltage where at 250 V. This is what we are given, and first we need to calculate the IA. So let's go to our formulas, our calculation formulas, and see how can we calculate IA from everything that we are given. We have R shunt, we have RA, we have IL and B. So let's go to our formulas, guys. Talking about formulas, guys, this is the list of formulas and the difference of formulas between generator and motor, guys. Just to clear out the difference, guys, look at this. Here the EMF we add, and here on motor the EMF we subtract, you see. And here the formulas are consistent, you see. It's only dealing with EMF, and then from everything that will help us find the EMF. And here we have new formulas, which is 2 Weber's NPZ over 60, which I will show you what each one stands for. And we have the constant, and we have the EMF. We can find the EMF within different formulas, you see, within different formulas, guys. But right now we are dealing with a shunt generator. So we are in here. A shunt generator is a parallel generator. So we're gonna tick off the given, what we are given, to see how we can get to what we must find. But before, let's see what stands for each one of this. If you couldn't see the formulas perfectly because of the big ink, you can just check it out from here, guys. So the EMF is equal to 2 flux NPZ over 60C. So E is equals to EMF in volts. Flux is equals to flux per pole in Weber's WB. N is equals to speed of the armature in R per minute. P is the number of poles. Z is the total number of armature conductors. C is the number of parallel paths, guys. And if it's a wave wound, it's just gonna be equal to 2. But if it's a lap wound, it's gonna be equal to 2 pole. You see, 2 pole. You're going to multiply it by 2 by number of poles. And here it's where we are looking when we are looking for the constant, and it represented by K is equal to 2PZ. We know that P is number of poles and Z is rev per minute, you know. Speed is speed, rev per minute over C. And we know that if it's wave, it's just gonna be out of 2, but if it's a lap wind, it's going to be out of 2P. And A is equals to KN, which K stands for this one. And we can also get N from the whole thing, guys. So that is it. There's also this formula, guys, What is important here on this formula, it's that 0,318 armature current Webers or flux PZ over C. It is what is important. Therefore, T is equal to 0,318 armature current, flux, number of poles, speed divided by C. And where IA is armature current, Webers is flux measured in WB, P is number of pole pairs, Z is total number of conductors, C is number of parallel paths. The same. If it's wave wind, it's just gonna be out of 2, but if it's lap wind, is going to be 2 times pole, guys. But since we still focused on the question, let's see from our formulas, if we have R shunt, R armature, IA, ILV, to find armature current, which formula we can use from shunt wound. I told you that shunt wound generator is a parallel generator, so let's check at parallel generator on how we can find the armature current. Okay, so solving for I shunt, right? Solving for I shunt, we say that I shunt is equals to V over R shunt. From our given, we know that voltage is equals to 250 and R shunt is equals to 200 ohms. From the calculator, 250 divided by 200, I get my answer to be 1,25. 1,25 A. 1,25 A. And since now we have the I shunt, you already know we can just substitute, because we said IA is equal to IL plus I shunt. We were given IL, which was 45, plus I shunt, which is 1,25. Calculated. $46.25. I find my armature current to be 46,25, which is the armature current. Okay guys, since we are done with armature current, and now we're going to solve the EMF. So let's go to our formulas and check which formula we can use. Don't worry about these formulas, guys. They'll be given on your exam question paper. You just need to know how to substitute and how to choose a formula. So since we are dealing with parallel, we are chilling here. So we have the EMF, right? Do we have B? Yes. Do we have RA? Yes. Did we solve for IA? Yes. So we are going to use this formula to solve for the EMF. E is equals to V plus RA IA. So for the EMF, we are going to use E is equals to V minus IA RA. We were given the voltage and it was 250. We just solve for IA, which is 46,25, which we're gonna times by RA. RA was 0,15. It was given. And then from the calculators, is that visible? From the calculators, minus 250, subtract 250 from 46,25 times 0,15. I think the lighting is much better now. So it's 46,25 0.25 times 0.15. I get my answer to be 243, right? 243 comma 0 6. Just gonna leave it here. I found my answer to be this. What did you guys find? Because normally my calculation, every time when I have to substitute and calculate, I always find the wrong answers. I hope this one is correct and you found the same one. Like I have said, I like to make mistakes. I don't know why. Remember when we are dealing with generator, we plus, we do not subtract. Okay, so the answer is 256 comma 94. Let me just round it off here. 94. 256 comma 94. Now we have the EMF. They want us to calculate what? Let's go to the question again. The power delivered in kW, in kilowatts. So let's check from our formulas. How can we calculate power? So here is our formula. How can we calculate power? Power is equal to IVL. Do we have V? Yes, we have V. Do we have IL? Yes, we have IL. So we just have to substitute. So power, right? Power is equal to IL times V. So did we were given IL, it was 45 times voltage, which is 250, and use your calculator. 45 times 250, right? Right, what did you guys get? I get 11,250. 11,250. I hope you got the same answer. But they wanted us to find the answer in kilowatts, right? So we divide it by 1,000, which is 11,25 kilowatts. And we are done with this question. We are done with the first question. Okay guys, the question says a series wound generator delivers a 20 ampere at 250 volts. If the series field and armature resistance are 0,1 and 0,2 ohms, calculate the magnitude of generated E and F. So let's write down the given. Number one, always write down the given. We are given delivers IL of 20A at voltage 250 V in series field. That means we are dealing with series circuit, series field and armature field. So RSE is equals to 0,1 ohm and armature resistance is going to 0,2 ohm. You see, calculate the magnitude of EMF. So we are looking for E while we have I, L, V, RSE, RA. So let's look at our formulas. Since we are dealing with a series generator, guys, this is part 2. If you didn't see part 1, go check it out because it has all the formulas from motor to generator. And I'm just gonna continue. I'm not gonna go back and start explaining the formulas. Please go to part 1. of series and generator motor calculations and check it out from there. Let's continue with the question. Let's go to our formula. A series wound generator, guys. So from here, let's check out what we are given. Are we given IL? Yes, we are given IL. We are given, we are not given RL, but we are given voltage. Yes, we are given voltage. We are given RA. We are given RA and we are given RS. So we have everything we need. Since in series IA is equals to ISE, which is equals to IL, they are all equal. If we are given one current, know that the current is equal throughout. That means we're going to use this formula, which have V. That means we have IA, RA, and everything. When we are dealing with series, IA is equals to IL, which is equals to ISE. Therefore, we were given current of IL, which is equals to 20A. That means everything is equals to 20A, because in series current are all equal. Therefore, you're going to use this formula. E is equals to V plus IA RA plus IE ISE RSE. Are we given the voltage? Yes, we were given a voltage of 250. 20 times RA. What was RA? It was given 0,2 plus ISE, which is also 20, times RSE, which was 0,1. So let's solve it. 250 plus 20 times 0,2 plus 20 times 0,1. 250 plus 20, which we times it by 0,2 plus another 20, which we times it by 0,1. I get my answer to be 256 voltage. And that's how we solve this question. Let's move to another question. The second question goes like this. A shunt wound generator delivers a 2,5 kilowatts power at a terminal voltage of 200 volts. If the shunt field resistor is 120 ohms, calculate the armature current. And after we calculate the armature current, they want the armature resistance if the generated E and F is 210 V. So let's write down the given. The given, what are we given? We are given the power. Remember, power is, okay, it's 2,5 kilowatts, right? And voltage we are given is 200 V. And the shunt field resistor, R shunt is equals to 120 ohms. So using this information, they want the armature current. So let's use what we are given to find a formula, a correct formula, so that we can derive or substitute answers to find the armature. Since they are talking about a shunt wound, know that the parallel is the shunt wound. So what are we given? We are given power. And power, it's I times V. IL times V. Right? We are not giving any I. By the way, we don't have any, we are not given any current, but we are given, we know we have V and we have P. So let's solve for V and P to find IL. So we just saw that P is equal to IL times V. So we are given power to be 2,5, right? 2,5 kilowatts, which I really want to turn it into watts. So 2,5 times 1,000 is 2,500. I'm turning it into watts. It's 2,500. 2,500, which is equal to IL times V. We were given V. V was 200, right? So IL is equal to 2,500 divided by 200. So what is IL? How much is IL? 12,5A. 12,5A, right? Right, we have IL, but let's go to the question again and see what they want of us. They said, calculate the armature current. We are still looking for armature current. We just found the IL. So let's go to the formulas again and let's write down the given again. Now we have IL, which is equals to 12,5, right? Now we have IL, which is 12,5. So let's check again. We are given power. We are done using power, right? We are done using this. We used power. Now to find IL. So I'm not sure if we're gonna use it again, but let's go to our formulas and check again which formula we can use to find armature current. So guys, they want us to find the armature current, right? Let's play tic-tac now. They want us to find armature current, right? They want us to find this. So I tick it. Do we have IL? Yes, we do. So I tick it. Do we have I shunt? No, we don't have the I shunt, right? But can we solve for the I shunt? Yes, I think we can solve for the I shunt. I shunt is equal to voltage over R shunt. Are we given the R shunt? Yes, we are given the R shunt. So we are using this formula. I shunt is equal to V over R shunt, because we are given the R shunt here. We have the R shunt, which is 120, and we have V. We have both. So let's solve. I shunt is equal to voltage over R shunt. Yes, we are given voltage. Voltage is 200 over R shunt, which is 120. So what is R shunt? 200 over 120. I get it to be 1,67 ampere. So we got this, right? If we got this, we can go to that formula again where we solve for IA. They said IA is equal to IL plus I shunt. So what is our IA? 12,5 plus 1,67. What is IA? Let's go. 12,5 plus 1,67. 14,17. Find my IA to be 14,17A. This is our first answer where we are solving for armature current. Now we can write it down on our given. So IA is 14,17. And let's continue. After they want us to find the armature resistance. The armature resistance if the EMF is 210. So here we are given the EMF to be 210. So let's write down our given. It's 210. So let's write down our given. We wrote it down, and now we can go to the formulas to check which one has the armature resistance, which have EMF, and what we are given. Now we get to here, guys. So they want us to find the armature resistant. Do we have V? Yes, we have V. Ticket. Do we have E? Yes, we were given E. Ticket. Do we have RA? We are looking for RA. No, we don't have, but do we have IA? Yes, we just found IA. So now we can use this formula because we have most of the variables than RA. You know, we don't have RA, but we are looking for RA. So we use this formula. So let's continue. So we use this formula, which is E is equals to V is generator X plus IA RA. So do we have E? Yes, we were given E. They said it was 210 voltage, 200 plus IA. We just got it to be 14,17 RA. So we take 200 this side, right? 210 minus 200 is equals to 14,17 RA, right? So what is the answer here? It's 10. 210 minus 200 is 10, right? So 14,17 RA, we're gonna have to divide it by 14,17. 14,17. So RA is equals to how much? 10 divided by 14,17. I get my RA to be 0,71. 0,71 ohm. Get my RA to be this, and this is the final answer, guys. I will be talking about motor calculations. Right now I was dealing with generator calculations, but I will be dealing with motor generations on part 2. Thank you guys for tuning in my YouTube channel. Please like, please subscribe, please share the video with others who need help, and please comment and tell me where to improve and how to improve. And let's keep growing, guys. Let's keep on learning, guys. Let's continue, guys. Please be blessed, be blessed, guys. Have a blessing day, and enjoy yourself. Thank you.